right? Now there are thousands and thousands of organic compounds. Tell me why we are talking about many compounds. What is the title there of the lesson? And it's compounds. Obviously, there are thousands and thousands of different type of compounds. Why? Because first of all, carbon is tetravalent. It can form chains, it can form rings. Okay, it can combine with different elements, right? And it can give rise to a number of compounds. Now, for the 10th standard, because it's just an introduction to the organic chemistry, we are going to do only 2 of them. Is that okay? Only 2 of them. One is ethanol and the other one is ethanoic acid. Let's look at ethanol. Ethanol. All is what? Alcohol. What is the functional group? OH. Sorry, OH. So they should have an OH. Okay, now you look at eth. 2. So can you write down the formula for ethanol? Come on, do it. First thing that you are going to. So write down the formula. Also write down the structure. All of you will write down the formula and write down the structure also. Because that is the first thing that you are going to learn about ethanol. You are already familiar with ethanol. Okay, because we have already done the functional group of alcohol. Yes, yes. Ether means it is 2 carbon. So we have got 2 carbon. I put a dash there. And there's an OH there. So you can put an OH here, you can put here somewhere in. So this is your structural formula for ethyl alcohol. You can put this OH on this side also. It's perfectly alright. So it is anyway C2. Then this is H5 and OH.
Can that OH be placed above?
Anyway. Okay. Right? So what is the first member of the alcoholic group? Homologous series. What is the first member?
Ethanol.
Methanol. Second will be ethanol. Third will be propanol. Fourth one will be ethanol. 5? So that is all. Okay, so each thing, depending upon the increase of the carbon atom, we are increasing and putting the same group, which happens to be the OH. You have already come across ethanol in your bio classes. Pyruvate is not ethanol. Where?
Breakdown of glucose in the muscle cells. Sorry, in the absence of oxygen.
Okay, so when you are talking about fermentation, process of fermentation, it leads to the process of formation of ethyl alcohol. Okay, now this sorry, ethyl alcohol is very, very useful because this is used nowadays as a substitute for fuels. You know, petrol and diesel has become very expensive. So what they do is they are mixing this ethanol with your diesel or fuel such that the cost can also come down and it becomes more efficient. We have already learned something about combustion. What does it tell us? Any hydrocarbon combustion will release what? Carbon dioxide, and it doesn't release. It releases carbon dioxide and water. Okay? So it is a complete combustion taking place. So ethanol is a very, very important industrial product which is got. Now how can it be done? Obviously you know something about sugar, right? How is sugar cane got? Sugar got is from sugar cane. Now when sugar cane has the juice has been extracted from the cane, what is left behind is molasses, which is nothing but your biomass which is fermented. So by the fermentation of this molasses, you are getting ethanol. Have you followed? Luckily for us, we realize that ethanol is a type of a fuel which can be generated. It is a renewable source of energy. Therefore, ethanol has become very, very popular. And in many of the countries, they are also using corn, barley, and such things for fermentation processes. So that's basically some extra information that you need to remember regarding ethanol. Second, when we say ethanol, obviously it is in the form of a liquid. Okay? But the boiling point is much lower than that of water. What is the boiling point of water? Celsius. Okay? So this boils much below that. So if you take in a test tube, you take methyl alcohol, it starts boiling at 78 degrees Celsius. Okay? So always when you are doing any experiment with ethyl alcohol, you have to be very careful because it has got a low boiling point. Right? So the first part of your lesson on the paragraph, if you look at your textbook, ethanol is a liquid at room temperature. Sometimes the questions will be, what are the physical properties and what are the chemical properties? So when we are doing the chemical properties, obviously we will have to be talking about the equations and what is the reaction. Now these are what we are talking about is only the physical properties. So how does it present? How is it present at room temperature? It's present in the form of a liquid. Okay. Next. For the melting and boiling points, obviously, they are asking you to refer to that table. Where is your table 4.1? Go back to the first page of the chapter. Of this chapter, on the first page, you have a small table. Did you notice that?
Yes.
Yes. Did you notice what is the boiling point? How much is it? 3? What? 351 what? K. So it is 351 K. Now I want you to tell me in C.
70.
What will you do? Minus. Do that. Do that. Do that. Okay. So in terms of degrees centigrade, it is 78 degrees Celsius. Okay. Similarly, obviously, you are talking about the boiling point, and we have seen the melting point. Right. Now, alcohol, unfortunately, has been misused. Though we know that alcohol is present in most of the fermented. Okay. So it is a source which can be used as in a beverage, like. But unfortunately, it can disrupt your central nervous system. So even this, I think you have completed in your bio classes. What is CNS? Have you finished this lesson? No. What is CNS?
Central.
Yeah, central nervous system. Central nervous system consists of your brain and your spinal cord. So if a person consumes excessive amount of ethyl alcohol, that itself will disrupt the functioning of a person. Okay, so you will have seen that people will lose their coordination. They'll probably, all the nerves are getting affected, and the reaction time to any type of an emergency is going to be less. Okay, so that is how you find that it causes a lot of other problems, social problems. So that is what one of the things that the government does is this ethyl alcohol, though it is obviously sold under certain under certain stores. Now, usually what happens is in the villages, they tend to misuse ethyl alcohol. Okay, so what they do, what the government does is it adds a little bit of methyl alcohol. Now, unfortunately, methyl alcohol is very, very poisonous. What is methyl alcohol? What is methyl alcohol? Methanol. This is methanol. Okay? Methanol. Did you understand why it is methanol? Okay? Now this is very, very dangerous because methanol, if it is consumed, it is getting converted into methanol. Methanol in the liver. Okay? And this methanol is very, very dangerous because it can bring about changes in your cytoplasm itself. So the cells begin to die out, and persons who are consuming a lot of methanol can also die. Now that is something that is happening usually in the newspaper. So many people have died because they have consumed illicit liquor. Okay, you must have seen in the news or the newspaper, such things do happen. Whereas poor people in the villages, they tend to consume this ethyl alcohol, which is already mixed with ethyl alcohol. Unfortunately, they do not realize it, and then of course it leads to death. Okay, not only affecting the optic nerve, but it also causes a coagulation of your cytoplasm of each of the cells, and that leads to instant death. So one obviously has to be very careful, and such things have to be avoided. Yes. Methanol, it should not be, because basically when we are talking about ethyl alcohol, that is safe up to a certain extent. Anything in excess, obviously we know it is wrong. But methyl alcohol is a definite no. Okay? But unfortunately, there's some kind of an illicit liquor which has been sold, and usually what they do is with ethyl alcohol, they mix up the methanol. Unfortunately, people do not know it, they consume it, and that's how it leads to mass death. So many people usually have it. Yeah, it is instant, almost instant. Did you understand? Yeah, it is almost, because it causes a population of a protoplasm. So how does any cell survive? So within a couple of hours, the person is dead. Not instant death. Obviously, a person is going to suffer and die. Okay, so that is the worst part of it. Right? Liquor is usually it is ethyl alcohol. If you're talking, why did they add methanol? Because methanol is much cheaper. So yeah, anything that is it's not a company. People who are doing some kind of an illicit business, that is how they are actually doing it. Okay. So in order to prevent all these things, of course, government is also doing a very good thing. They are adding a blue colored dye, so to indicate that it should not be used. Methanol has got a lot of uses in the industry. It's not that a lot of uses in the industry because it can be used also as a solvent. So we'll come back to that a little later. So just giving you a little background regarding how the ethanol and methanol, okay, those are the two things that we have to be very careful about. Now let's see what else has been mentioned here. Look at the first paragraph once again. Okay. How is it used? Look at your textbook, the first paragraph there. Ethanol is commonly called as alcohol, and it is the active ingredient of all alcoholic drinks. In addition, because it's a good solvent, it's a very, very good solvent, industrial solvent. It is also used in medicines like tincture iodine, cough syrups, and many other tonics because it is capable of dissolving many of the ingredients. Okay. Ethanol is also soluble in water. Consumption of small quantities of dilute alcohol causes drunkenness. And that too what we are talking about in dilution, right? Even though this practice is condemned, it is a socially widespread practice. However, intake of even a small quantity of pure alcohol, what is pure alcohol called? It's called absolute alcohol. Underline that. Okay, make a note of it. What is absolute alcohol? Is nothing but 100% pure alcohol. It can be lethal. What is lethal?
Very deadly.
Person can actually die. Okay. Also, long-term consumption of alcohol leads to many health problems. Have you heard of liver cirrhosis? No. No? Liver cirrhosis, where the liver cells are actually getting damaged. Cirrhosis, yes. Okay, due to continuous drinking, obviously the cells of the liver is getting damaged. Sorry?
Why is pure alcohol?
Why it is dangerous? Yeah, obviously because it is next paragraph. How do alcohols affect the living beings? So you have another paragraph regarding the biological aspect of how it is affecting the living beings. Okay, right. Why you're getting into fits of drink some water. Okay, so that enough. Sorry. Right? So that is basically regarding, if I'm asking you what are the physical properties of ethanol, what are the various things that you should mention? Solubility, okay, it's liquid. Boiling point is how much? 78 degrees Celsius, or if they're asking me, if they're asking me, okay, so that's basic. Now, as far as your chemical reactions are concerned, we are having only two reactions. Did you see? There's one reaction with sodium and the other reaction is how we are talking about a dehydration process. Okay. Come on, take down in your notebooks. First of all, you have written down the formula, structure formula. Okay, right. First, physical properties. Make a note of it. First point. Liquid at room temperature. First point. Liquid at room temperature. Second point. Boiling point is 351 K. Third point. But you can also write down the melting point since they have already given. How much is it?
What is the boiling point?
351.
What's the melting point?
270.
What's the melting point?
Boiling point they have given 351. Melting point is 156. Sorry, melting point is 156.
Get it?
Yes, it's okay. Okay. Next point. It's a good solvent. Third point, it's a good solvent. And in bracket, write down whatever it is next point.
You have to write it back.
Yeah, in brackets, write down. Used in medicines. It is a good solvent. And in bracket, write down its uses. Used in medicines.
After it's a good solvent, right?
In under good solvent, yes.
Medicine and
Used in medicines such as tincture iodine, cough syrups. Suppose a person gets wounded, then they clean it with iodine solution. So that is called as tincture of iodine. No, it's not Dettol. It's tincture of iodine, something that's some brown in color. Next one. And betadine, which you use it as a mouthwash or gargling, a dark brown. That's yes. That basically has got. Okay. Yeah. Betadine can be available as a ointment. It's also available in the form of gargles. Okay, so if it is available for gargling, then obviously it is having this. Next point. Come back. Class. Come back.
And there are alcohol-free mouthwashes as well.
As a diluted, yes. As listed, they have also have some 5%, 2%. Next one. Okay, have you written that it is soluble? It's a good solvent. Right. That's more than enough. Okay, one more point that you have to remember is not as a use of whatever it is. What is absolute alcohol? Absolute alcohol. Yes, take it down because it can come in your MCQ. Pure alcohol is called as absolute alcohol. First of the reactions that we are going to be talking about is reaction with sodium. So what are we talking about? We are taking ethyl alcohol. So C2H5OH. I am writing down the structure in this form so that it becomes easy for you to understand the reactions. Okay. So now we have got reaction with sodium. What's going to happen? This hydrogen part of it is going to be removed. Sodium is going to come instead. So what's happening here? This part of it remains the same. Did you get it? There's an O and an Na. Okay. So that is your sodium ethoxide. Okay. And of course, what happens to this hydrogen? How many hydrogens are released? Only one in this particular case. So obviously we know that hydrogen does not exist as an atom. There are two of them. So if you want two of these, this will be 2 and this will also be 2. And this will also be 2.
Ma'am, I did not understand what you were given about.
This one is given out, isn't it? Okay. So we require 2 of them. So that entire thing we have to take 2 of them. So it's such that it is going to be balanced. Did you understand or no? So we can write it down in this format. All of you please take down. Reaction of ethanol with sodium. So you got C2H5ONa plus H2. There are 2 here. So this hydrogen also becomes 2. This whole lot becomes 2. Sodium also becomes 2. Hydrogen is a gas. So we put an upward arrow, or we can also write it as G. So this is sodium ethoxide.
So the other last line, we have like S there as well.
Where?
In the C.
Here. All this? Yeah, all this is there. What will come at the end of each of these bonds here, children?
Hydrogen.
So So there's no need for you to write down this. I've just written it down so that it becomes easy for you to understand. Okay? So in your examination, this is not needed. Only that is needed. Okay. So now my question is, how do you know that hydrogen gas is given out? What is the test? How do you know it is not? Hot, yes. Okay. Or probably if you take that gas and you're passing it in lime water. Lime water is for what?
CO2.
Obviously, it is not carbon dioxide, so it will not turn milky. Okay. And once you take a burning splinter, it burns with a pop sound, so you know that hydrogen has been given out. Is that okay? Just put one question there. Test for hydrogen, you should remember.
In the text, it's given in another format, CH3, CH2ONA.
Yes. So what is it? So you can see this.
Yes.
Okay. All of you please pay attention here. Shh. Please pay attention. I said C2H5OH. That is what we have started off with. Can you understand what I'm saying? Look at the board, everyone. Don't get distracted. Now I said that H part of it is released. If this is H which is released, obviously this will be O minus. Do you understand? Okay. And the sodium which is coming here, that has to be obviously Na. So it is C2H5O negative and this Na plus is coming. Do you understand? Right? Okay. So there's no need for you to show this. This basically they are telling you what is the radical which is left if the hydrogen has been taken out. Okay. So what is the formula for sodium ethoxide?
C2.
Sodium ethoxide. Sodium is this, and this part of it is sodium ethoxide. Is that clear? Yes. We go on to the next one, where we're talking about dehydration reaction. Once again, I'll be writing it down in the form of a structural formula so that you understand it very clearly. Take down the second one. Okay, the second reaction is dehydration reaction of ethyl alcohol. Dehydration. is this formula?
C2H5.
That is your ethyl alcohol, isn't it? So this is nothing but your ethyl alcohol. If you treat it with an agent like concentrated sulfuric acid, did you notice that in the textbook? What have they given? Concentrated. This is concentrated sulfuric acid. Sulfuric acid is acting as a dehydrating agent. Dehydrating means what? Hydrating means what? Hydrate is water. Dehydrating means what? Removal of water. So can you see the water is getting removed here? Samjha? Okay, so let's write down what is left over. Let's write down. If water has been removed, this is what is left over. But is this formula correct? Is that formula correct?
No, ma'am.
Why? Carbon should have 4. So a single bond will change into
Double bond.
Did you see that? Yes. So this is one of the methods which we use in the industry for changing a single bond into a double bond. Have you seen that? Okay. So we start off because there are a number of products which can be produced. Polyvinyl chloride, the starting material is this. Ethylene is the starting material. So for the production of ethylene itself, we start off with ethyl alcohol, do the dehydration agent, okay, reaction, so that we are getting ethylene. Now what is the IUPAC name here? Double bond head. So what will it be? Ene.
E.
Anna, this is ene. And 2 carbon is what? H. So what is it?
Ethylene.
It is ethylene. Ethylene. So ethylene itself is a starting material or it is a raw material for many of the other materials which is required in the industry. Why is it called as a dehydrating? Because water has been. So what is the dehydrating agent here? Sulfuric acid is a dehydrating agent. Take down one point here. Look at your textbook, second one. Reaction to give unsaturated hydrocarbons. So when are we using this type of a reaction? When we want, very good. When we want unsaturated hydrocarbons. So the textbook or the question papers will not give you a direct question. Yes. Sorry. Concentrated. It will not work with dilute. It has to be concentrated hot sulfuric acid. Okay. So the questions that you might expect in your examination will be, listen to me. Questions that could be asked, give a reaction to form an unsaturated hydrocarbon. That's all. So आपको याद रहना है that we are starting off with okay, ethyl alcohol. Take down the question. Take the question down quickly. Give a reaction to form an unsaturated hydrocarbon. Yes.
Can you explain once again what you did with?
Yeah. Okay. And at what temperature? Obviously, the temperatures are very high. Okay, so heating ethanol at 443 K. How much is 443 K in terms of centigrade? Minus 273 karo. Chilli. How much is, what is it? 170. 170. Okay, so you can remember that at a temperature of 443 K. So that means hot concentrated sulfuric acid. What is it that you did not understand? Is it here or no?
Yes, ma'am.
Okay. Did you understand this part?
No, ma'am.
From the beginning only,
Yes,
I'm
ma'am.
telling you. From the beginning only, I'm telling you. Ethyl alcohol, I have written it down in the form of the structure so that you understand it.
Yes,
easily.
ma'am.
Okay. So what is happening? It's a dehydrating agent. So hot, concentrated. CONC is concentrated. I'm always going to be using this. What is this? And what is this?
Diluted,
Concentrated. Okay. So that's your concentrated sulfuric acid at a very high temperature. It is acting as a dehydrating agent. Okay, so that means water has been taken away. So you have water H2O which is taken away from here. I've written the formula here, but then you realize that single bond is not correct. The single bond has to be converted into a double bond because each of the carbon should have 4 covalent bonds. So you are converting a single covalent bond into a double covalent bond. So that means a saturated is getting converted into an unsaturated hydrocarbon. Is that okay? Clear? Yes. Right. So we look at the textbook once again. After the equation they have given you, therefore the concentrated sulfuric acid can be regarded as a dehydrating agent which removes water from ethanol. Write it in your notebook. Dehydrating agent. Sometimes in examinations they can ask you such funny things, okay? Just one word here and there. Dehydrating agent is hot concentrated sulfuric acid. Or they may give you in form of an MCQ. Identify a dehydrating agent. They may give you K1O4, K2Cr2O7, okay, H2SO4. Then you must remember that H2SO4 is acting as a dehydrating agent. Okay? Then, I've already spoken to you about the last paragraph and also about alcohol which can be used as a fuel. That's more of an information. Next, we are going to be talking about ethanoic acid. Ethanol only 2 reactions, nothing much. Okay. As you go to the higher classes, there are many more reactions that you will be learning. These are some of the basic ones that we are having for the 10th standard. Is that okay? Right. How will you write this instead of writing it down in the form of the structure here? Look at the board, everyone. We can also write it as C2H5OH. That's all. Right? You will not understand how that water is going out. That's why I put it down in the form of a structure. Did you understand? In the textbook, they have given you this format. But I have drawn it in the form of a structure to show you how it is getting written. Next one. Next is we are going to be talking about ethanoic acid. What is the functional group for an acid? Very good. Oil is correct. Functional group क्या होगा?
Carboxylic acid.
You said right, carboxylic acid. What will come there?
COOH.
Okay. Now we want to find out what is the formula for ethanoic acid. Eth में क्या होगा? 2. Eth is 2. Okay. So we have got 2 carbons, and your functional group is COH. So this is COH. Ethanoic acid. What is this? CH3.
COOH.
What is this acid called?
Acetic acid.
Correct. Acetic acid is the common name, which is
Ethanoic
also
acid.
called as ethanoic acid, as alipac acid. Okay. Now this acid, all of us are very familiar because it is used very dilute. Okay, about 3 to 5% of ethanoic acid, diluted one. They use as vinegar. Are you familiar with vinegar?
Yes.
Chinese food. Okay, so that's your vinegar. Did you see that? Okay, so that's very dilute acetic acid which is used as vinegar. Right? Now, have a look at it. What are the physical properties before we go on to that? Yeah. Ready? Let's look at the physical properties first. It's commonly called as acetic acid. Belongs to the group of acids called carboxylic acid. 5 to 8% solution of acetic acid in water is called vinegar. Okay, all these points we must note down because it could be asked for your, questions, 1 mark questions. And it is widely used as a preservative in pickles. Melting point 290 K. How much is it in C? 290K is how much?
27.
No,
Sorry.
17.
Sorry.
what does it tell us? Melting point. This is your melting point of ethanoic acid. What does it tell us? When does water freeze? 0 degrees Celsius. Okay. Water at 0 degrees it is solid. But if you talk about ethanoic acid, it becomes a solid at 17 degrees. That means, as the temperatures begins to drop down, okay, you find that it begins to solidify at 17 degrees Celsius. That's why it's called as glacial acetic acid. Why glacial? Because it solidifies almost at 17 degrees Celsius. Very important because they'll ask you what is glacial acetic acid. Okay? Then, the melting point of pure ethanoic acid is 290 K and hence it often freezes during winter in cold climates. This gives rise to its name glacial acetic acid. Mark it in your textbook, I'll make you write it.
-2 डिग्री होता है वो क्या ये जम जाता है क्या?
Yes, obviously. At 17 degrees only, so as the temperature begins to drop, anything lower than 17 degrees, it will be solidified for this particular purpose. 100%. Okay? Then, a group of organic acids called carboxylic acid is characterized by the acidic. What is an acid?
Which is
Very good. In terms of your chemical nature, what is happening? Let's take a example. Litmus.
Litmus red. Reduces pH below 7. Releases H plus iron.
That's very good.
And
So, turning blue litmus to red. Okay. Most important is litmus paper.
It varies from color to color.
It releases hydrogen.
मैम ब्लू लिटमस पेपर और रेड लिटमस पेपर दोनों अलग होते हैं इसको सेकंड क्लास में लेके वापस
You get in the habit of speaking in English. Semi.
Before it came to any base or acid, what was it?
he is asking like if there is any standard color normal color
Yes, no. For universal paper is also the universal pH indicator paper is there. That's what it's in color of.
so there is no like stable color of the litmus paper like purple or
If you're talking litmus, only 2 colors. If it is the universe, yes, blue and red. Okay. Okay. Ready? Physical properties of. Start writing. Physical properties of ethanoic acid. Not only physical properties, I'll just give it to you in bullet points so that you remember all the points which can be asked. Common name?
Acetic acid.
Acetic acid. Acetic acid is common name. Second point, vinegar. Composition of vinegar. How much is it?
5 to 8%.
5, they have given us 5 to 8%. Solution of acetic acid in water.
5 to
8.
Okay. Melting point.
290
290 K
17 degrees
Celsius. Okay, 290 K, have you written? Glacial acetic acid. Right. Glacial acetic acid at low temperatures. That is obviously below centigrade. 290 K. Acetic acid freezes during winter. Okay, another one. Because it is acidic in nature, what will be the change in the litmus paper? Blue to red. Make a note of it. And when you want to compare acetic acid with, let us say, sulfuric acid, it's a weak acid or a strong acid?
Weak acid.
Very weak acid. Okay. So pH of acetic acid, will it be more than H2SO4 or will it be less? pH.
More, basically.
Yes. Remember the scale? Yes. First one. Now if you look at the textbook, we have 1, 2, 3. There are 3 reactions. Okay, the first of the reactions we are doing is we are doing is esterification. Very, very important. Esterification is usually asked. You are taking okay. What is that you have taken?
C3.
What is this?
Acetic acid.
Acetic acid. Very good. So on one of them, we have taken acetic acid. Second thing is we have taken what is this?
Ethanol.
That is ethanol. Did you notice the functional group? All. So it is ethanol. Here the functional group is oil. So it is an acid. Yeah. So basically when this begins to react, you are having an ester. It is an esterification. You see the name? Esterification. C, yes, COOH. Okay, so the H part of it is released. Here this H is released, and from here OH is released. So this part will combine with this part.
What do you mean
Let me just finish. So let us see what is going to happen here. You will have the same thing, CH3, and there's a COO, and there's a C2H5. This is an ester. An ester will have one R group and the other one is an R dash. It can be any group here. So you will have an R group, R, COO and O, R dash. This is one group. Okay, this group I am writing it as R. This group is the other hydrocarbon.
But R equal to
Because it's usually used this particular notation. Where R is nothing but a methyl group and ethyl group. So this is a methyl group. Did you notice it is a methyl group? Instead of an ethane, we are using methyl. Here it is instead of an ethane, we are using methyl. Okay, so this is R. So this is an ester. Okay. What is a ketone? Ketone is C double bond O. This is a ketone.
Yes.
Okay, this is an ester. Do you understand? This is a functional group. It is
But then
ester.
also
This is a functional group which is not given in your textbook. See that functional group, there's one small table, they have given ketone but they have not given ester. So this is your ester. Okay. Did you understand what is happening here? One OH from here and one H from here is taken out and that is leading to the formation of an ester. Okay. Now esters have got a very nice fruity flavor and a smell. See, as those, especially the vanilla flavor, the rose flavor that we use for perfumes, for cooking, baking purposes and all. Yes, it's nice. For baking purposes. Why? Shh, 1 minute, let me just tell you. That's usually made up of esters. Okay, even for perfumes, they modify to get the right type of a perfume, like a fruity, or it can be a floral, okay, it can be a woody flavor, so on and so forth.
And perfume
So,
also,
sorry?
perfume also consists alcohol, right?
Yes, this is alcohol. Of course it is alcohol. Did you get it? Come on, take it down quickly. Yeah.
During the textbook, they have given a structure of a keto.
COO, there's an O also, extra O. This is a ketone.
Yes.
This is a ketone with only one double bond. See, did you see an ester here? There's one double bond and there's an O also extra.
Ma'am,
And what is the textbook? It is given the structure of.
yes, ma'am. It is given only one double bond over there. Only one double bond.
No, ma'am, leave it.
No, ma'am. It is also
Double bond and there's a O.
Understood, understood.
And there's an extra carbon. This carbon is extra.
No, that is an old book, there's a display. Have you all taken it down? Okay. Now, on the board I have shown you the structural form. I spread it out to show you how the molecules are undergoing a reaction. Okay. So, but you don't have to write it that way. You can just write CH3COOH plus C2H5OH. Write it down in the way that is given in your textbook quickly, so that you get used to that format. So you will write it as CH3COH. Right, so
Ma'am, what is
plus of course water is there because it is between. Ready? Okay, read the last paragraph. Generally
Esters are sweet smelling substances. These are used in making perfume and as flavoring agents. On treating with sodium hydroxide.
Right, something funny.
No, ma'am,
Then?
he's
But yes, enough. Okay. So you understand that many of these organic compounds are used in different type of industries. For the manufacture of perfumes, for the manufacture of medicines. Okay, ethyl alcohol, we have seen that it is used in the manufacture of medicines. Okay, and also for making different type of flavoring agents. Now the second part of it, did you understand why it is called esterification? Because an ester is produced. Did you get it? Because there is an ester which is produced. Now what I am telling you is, suppose the same reaction is taking place with the help of sodium hydroxide. Here what did we use? Here we have used an alcohol to produce an ester. Look at the next slide. I'm going to ask you some questions about it very carefully. Okay. On treating with sodium hydroxide, which is an alkali, the ester is converted back to an alcohol. Okay, so the reverse reaction also takes place. And sodium salt of carboxylic acid. Do you understand what we are talking about? We are already having an ester. Okay, so this ester, if further you are going to talk or you are going to react with sodium hydroxide, yeah, I'll pick it up after this. Don't worry. Don't worry. I'll pick it up after this. Okay, so it forms a sodium salt of the carboxylic acid. So here what happens is CH3COONA. Did you see that? What is happening? This sodium is once again coming here. It forms a sodium salt of carboxylic acid. And once again this OH part of it will get added on here and it forms ethyl. Did you understand? That is the reverse reaction. Okay. One announcement. I am reminding you once again for physics class, revise and come, and please remember whatever I told you. Don't mess it up.
मैम के दूसरे क्लासेस लेते हैं
शायद बहुत ही बकवास है
Yes.